Okay, let's look at how we would calculate the volume and the surface area of a cylinder shape instead, a cylindrical shape. Okay, well, if we say that we've got a nice easy radius here, let's say we've got a radius of 2 centimeters, and we have the height of our cylinder is 5 centimeters. Then we would calculate the volume of this cylinder as being the area of the base multiplied by the perpendicular height. So area of the base, AB. We know that for any circle, we can calculate, because you have to imagine this is a three-dimensional shape, so it's a pure circle on the bottom. The area of the base of a circle is pi times the radius squared, pi r squared. So in this case, it would be pi times the radius squared, 2 squared, times the perpendicular height, which is 5 centimeters. And the radius squared will be centimeters times centimeters, so it will be in the units of centimeters squared. So we get 20 lots of pi centimeters cubed volume. If we assume that pi is 3, we've got approximately 60 centimeters cubed as the volume of water that we could put into this cube if we were going to measure it in centimeters cubed or milliliters. But what would be the surface area of the whole of this shape? Imagine that this shape is a little cylindrical block with a top and a bottom and all the way around. Well, the area of the ends is really easy for us to calculate. The area of the top and the area of the bottom will be the same circle, so it will be 2 lots of pi r squared, which we already know here. 1 lot of pi r squared is 4 pi. So 2 lots of pi r squared would be 8 pi centimeters squared. And if pi is 3, 8, 16, 24, approximately 24 centimeters squared. And that would be the area of the top and the bottom. So what we have to do is we have to imagine that here is our cylinder. We take a piece of paper like this. We can see the cylinder. We've just calculated the area of the radius. Using the radius, the area of the top of the cylinder and the area of the bottom of the cylinder by just calculating pi r squared as normal. The question is, how do we know how much the area of the paper is now, the outside of the cylinder? Well, we can actually spread this paper out like this. We've made a cylinder out of it. What is this central part of the cylinder made of? Well, look, it's just a rectangle that has a vertical height, approximately the same as the paper, and it has a length, and the length of that piece of paper we can calculate because we do know what the length of the outside circumference of a circle is. We know that the length or the circumference of the circle is just pi times the diameter, or 2 pi r. 2 times pi times the radius gives us the length of the outside of a circle, which is the same as the length of our rectangle when we're working out the surface area. So the circumference of the circle multiplied by the perpendicular height will give us the dimensions of the rectangle that surround this cylinder. Okay, so what then is the length? Well, here we have, if pi is approximately 3 again, we have 2 times 3 times the radius, which is 2. So we get 12 centimeters as the length. 2 times pi times the radius. So we know that the outside circumference, so the circumference multiplied by the height will give us the area around the middle of the cylinder. The rectangular block. So the circumference, we know it's 12 centimetres multiplied by our 5 centimetres perpendicular height is 60 centimetres squared. So the total surface area of this cylinder will be the area of the central cylinder, the rectangular area on the outside of our cylinder, plus the area of the top, plus the area on the bottom. So it will be 60 centimetres squared, plus the area of the top and the bottom, with 60 centimetres squared, plus 24 centimetres squared. So the total surface area will be 60 plus 24, which will be 84 centimetres squared. The bottom surface has an area of 12 centimetres squared. This is not to scale. The bottom circle has 12 centimetres squared. The top one has 12 centimetres squared. And the middle bit in the middle has an area of 60 centimetres squared, giving us a total surface area of the whole cylinder, top, bottom and the sides, of 84 centimetres squared. And this is how we calculate the surface area of a cylinder and the volume of the cylinder. Base area times the perpendicular height. If we were actually going to change this, instead of it being a cylinder, let's imagine that it was a cone instead. What would we do then? Actually very similar. We'd use almost the same formula for the volume. Let's just calculate the volume of a cone. It's the same formula, area of the base times the perpendicular height, but because it's a cone, it's only a third of the volume. So we would divide all of these factors by 3, which would give us 20 centimetres cubed. So quite interesting, with both cones and pyramids, it's actually the same as the volume of the shape as though it was a cylinder, and then just divide that volume by 3. So a third of the area of a cylinder is the area of a cone. A third of the area of a cuboid is the area of a pyramid. So that's a useful technique to remember then at the very end as well.